Number 8, we want to find the absolute max and absolute min of this function on an interval. So when we're finding the absolute max, absolute min of an interval, of a function on an interval, we first look for critical values between the endpoints 1 and 5. All right, so let's do that first. So we want to see if we have any critical values. So we're going to take the derivative and set it equal to 0. And we get x equal 2. So that's our critical value, and it's between 1 and 5. All right, so to find the absolute max, absolute min, all we have to do now is check what the value of our function is at the various points. Like first of all at 2, and at the endpoints 1 and 5. So these are the places where the absolute max, absolute min could possibly occur. Okay, so let's start substituting f of 2. Well, that's 2 minus 2 squared. That's 0. F of 1, that's 1 minus 2 squared. So that's minus 1 squared. That's 1. And f of 5, that's 5 minus 2 squared. That's 3 squared. That's 9. So here's our max. Okay, the max is at 5, 9. And here's our min. So the min is at 2, 0. In number 9, we want to find where f is increasing and decreasing, and find relative max, relative mins. So that all has to do with the first derivative. What we're going to do here is we're going to do a plus minus analysis of f prime, and that'll give us the information that we need. Okay, so let's take f prime of x. Here, term by term, we have 3x squared minus 24x. For the plus minus analysis, we want to see where is this equal to 0. So first let's factor this. We can start by factoring out 3x. Okay, and that would be x minus 8. 3x times x minus 8. And we want to see where is this 0, so we can put those points on the number line. Well, that would be at x equals 0 and at x equals 8. So we're going to do our analysis, putting 0 and 8 on the number line. And we'll just check to the right of 8. If we substitute in 9, we get something positive. Let's substitute in 1 between 0 and 8. If we substitute in 1, we get positive, negative, so that would be negative. Here, let's substitute in minus 1, and we would get negative, negative, so that would be positive. So that tells us that f is increasing, decreasing, increasing. Now for the max mins, we'll just substitute in 0 into our original f function, and here we'll substitute 8 into the original function. All right, substituting in 0 into here, f of x, we get 0, 0. And that will be a max. You see how it goes up and down? That's a max. And now substituting in 8 into the original. So for f of 8, we get minus 256 for the y-coordinate. So that's our min. For 9b, again, we're going to do a plus-minus analysis of the first derivative. So let's do the product rule over here to take the first derivative. So here we go. First times derivative of the second, that would just be 1, plus derivative of the first, that would be 3 times 2/3 x to the 2/3 minus 3/3, that comes out to negative 1/3, times the second. All right, let's reduce that, and let's write this as a single fraction. So here we have a fraction. We have in the numerator we have 2 times x minus 2, and in the denominator we have x to the 1/3. And now we're going to add these fractions together because to do the plus minus analysis, it's convenient to have this in fraction form, and then we'll just put the zeros of the numerator and denominator on the number line. All right, so the common denominator would be x to the 1/3, so we'll multiply this first fraction, top and bottom, by x to the 1/3. Notice that x to the 1/3 times x to the 2/3, when you add those exponents, we just get x to the 1. Okay, so here we have under one denominator now, x to the 1/3. Here we have 3x. All this is 3x plus 2x minus 4. Okay, so that's 5x minus 4 over x to the 1/3. The numerator is 0 when x is equal to 4/5, and the denominator is 0 when x is equal to 0. So we're going to put these on the number line. In fact, these are both critical values. Where f prime is equal to 0, that's a critical value, and where f prime doesn't exist, but where the function f of x does exist, that would be also a critical value. So that's the case here. Here, f prime doesn't exist at 0, but f does. All right, so we have two critical values, and they're two different types of critical values. Anyway, we're going to put them both on the number line. Zero and 4/5. Notice I did a closed circle at 0. That's because our function f does exist at x equals 0. So I indicate that with a closed 0. Now for the analysis, if we substitute in something bigger than 4/5, let's say we substitute in 1, for example, 5 minus 4 over 1, that's positive. All right, here let's say we substitute in 1/2. So then here we'll have 5/2 minus 4. Okay, that's negative, so this will be negative. And if we substitute in, let's say, minus 1, we have minus 5 minus 4, that's negative over negative, and that would be positive. So we see on this interval, from minus infinity to 0, we have increasing. In the middle here, we have decreasing. And here we have increasing. So 0 is a max. And if we substitute in 0 into here, we get 0. And this is a max. And 4/5 is a min. And if we substitute in, well, we'd have to use a calculator to get that, to evaluate that. So I'm not going to evaluate it. I'm just going to write 3 times 4/5 to the 2/3 times 4/5 minus 2. So I'm just substituting in, but I'm not going to bother evaluating. And that's a min. All right, let's start by finding f prime of x so we can get max mins and intervals of increasing, decreasing. All right, we get that information from f prime of x. We're going to use the quotient rule here. So in the denominator we have x minus 5 squared. Put the x minus 5 here. Derivative of the numerator, that's 2x. Minus derivative of the denominator is 1 times the numerator. All right, let's simplify that numerator. So we have multiplying through, we have 2x squared minus 10x minus x squared plus 16. All right, again, simplify this 2x squared minus x squared. I'll just write it on top. That's x squared, and then minus 10x plus 16. Now this numerator factors, All right, so let's write it in factored form. We have x minus 8 times x minus 2. So to do our plus minus analysis, we're going to put 8 and 2. And these are in fact critical values. And we're going to put x equal 5, where this one is not a critical value. It is a vertical asymptote. All right, so let's do our evaluation. So we're going to put 2, closed circle, 5, open circle, and 8, closed circle. Remember, 5 is in fact a vertical asymptote, so it can't be a critical value. But we need it for the plus minus analysis because the sign can change when we go through 5. All right, let's see what happens here. Let's substitute in, let's say 10, and everything is positive. Let's say 6, and we have negative, positive, positive, so that's negative. Let's say we put in 3, and we have negative, negative, positive because of the square. Let's put in 3, and we have negative, positive. 3 minus 2 is positive. Negative, positive, and positive because of the square. So that would be negative. Negative, positive, and positive. Okay, so that's negative. And let's say we put in a 1 or 0. Let's say just 0. And we have negative, negative, positive because of the square. So just negative, negative, that would be positive. So we see f is increasing, decreasing, decreasing, increasing. So here we have a max, and here we have a min. And if we substitute back into f of x, the max is at 2, comma f of 2. And here the min is at 8, comma f of 8. And here are the values of f of 2 and f of 8. So here we would just put a 12. And here 48 over 49. All right, let's do this last one. Again, f prime of x minus 2 squared, x minus 2. Derivative here, 2x minus 3. Minus derivative of the denominator times the numerator. All right, let's just simplify this as much as we can. All right, multiplying this, we have 2x squared. Here we have minus 4x minus 3x, that's minus 7x. And here we have plus 6 minus x squared plus 3x plus 4. That would be x squared, and this is minus 4x, and this is plus 10. So we want to put the zeros of the numerator and denominator on the number line. Now this numerator has no zeros. The way we see this is by using the quadratic formula, and we can see that b squared minus 4ac is equal to 16 minus 40, which is negative. Okay, that means no real solutions. So we only put x equal 2 on the number line, and just the zero of the denominator. Okay, an open circle at 2. And if we substitute in 10, for example, the denominator is positive, and the numerator will be positive as well. And let's say we substitute in minus 10, then the same thing happens. The denominator is positive, and so is the numerator. So that means this function is always increasing. and no max mins.